Had the asteroid that hit Earth 66 million years ago struck nearly anywhere else, some dinosaurs, and perhaps other species like this flying reptile, might have survived, according to a new study. Mark Garlick, via science source. Dinosaurs reigned supreme for more than 160 million years. The dynasty came to a cataclysmic close 66 million years ago when an asteroid crashed into the Yucatan Peninsula in Mexico at a site now known as the Chicxulub crater, paving the way for mammals, and eventually humans, to inherit the Earth. But had the extraterrestrial impact happened nearly anywhere else, like in the ocean or in the middle of most continents, some scientists now say it is possible dinosaurs could have survived annihilation. Only 13% of the Earth's surface harbored the ingredients necessary to turn the cosmic collision into this specific mass extinction event, according to a study published Thursday in the journal Scientific Reports. I think dinosaurs could still be alive today, if the asteroid had landed elsewhere. Kunio Kaiho, a paleontologist from Tohoku University in Japan and lead author on the study, said in an email. Other researchers questioned the findings. When the asteroid, which had a diameter about half the length of Manhattan, struck the coast of Mexico, it found a rich source of sulfur and hydrocarbons, or organic deposits like fossil fuels, according to the researchers. Scorching hot temperatures at the impact crater would have ignited the fuel. The combustion would have spewed soot and sulfur into the stratosphere in sufficient quantities to blot out the sun and change the climate, setting into motion the collapse of entire ecosystems and the extinction of 3/4 of all species on Earth. A shaded relief image from NASA of the Yucatan Peninsula, showing the Chicxulub impact crater at upper left. NASA-JPL. The Chicxulub impact spewed an extraordinary amount of black carbon, or soot, for the rocks, the researchers said. That in turn launched nearly 60 Hoover Dams worth of soot into the upper atmosphere, cooling the Earth's surface by as much as 18 degrees Fahrenheit, they said. Not every place on the planet has the same amount of fossil fuel reserves and sulfur trapped beneath its surface. Locations with less hydrocarbons would have jetted less soot into the sky upon impact and created a smaller cooling effect around the globe. So Dr. Kaiho set out to determine the mass extinction hotspots in the Mesozoic real estate market. He created a map of what the world looked like 66 million years ago and used present-day measurements of sedimentary rocks and organic compounds to estimate the global distribution of hydrocarbons during that time. Dr. Kaiho's co-author Naga Oshima, a senior researcher at the Meteorological Research Institute in Japan, created a model that simulated asteroid impacts that ejected varying amounts of trapped soot from rock. Only areas with the highest amounts of hydrocarbons released enough soot into the stratosphere to cool the climate to catastrophic levels. 87% of Earth's surface places, like most of present-day India, China, the Amazon and Africa, would not have had high enough concentrations of hydrocarbons to seal the dinosaurs' fate. But if the asteroid had hit marine coastal areas thriving with algae, which would have included present-day Siberia, the Middle East and the eastern coast of North America, the bang would have been about as devastating to the dinosaurs and life on Earth as the Chicxulub impact. Scientists not involved with the paper criticized the underlying research. The idea that location is important for an impact, I think, is absolutely correct, said Sean P. S. Gulick, a marine geophysicist from the University of Texas at Austin. But he questioned the author's assumptions on where the soot came from and how it affected the climate. Scientists agree that the planet was blanketed by soot after the impact, but they argue over how it got there. Dr. Gulick said the asteroid impact most likely hurled fiery debris into the sky, which then rained down and ignited firestorms around the world within hours of the crash. The wildfires, he contends, not the burning fossil fuels at the impact site, were what released immense amounts of soot into the stratosphere. Dr. Gulick said his previous work drilling into the Chicxulub crater also showed only small amounts of hydrocarbons were present at the time of the impact. Natalia Artemivra, a senior scientist at the Planetary Science Institute in Tucson, added that soot played a smaller role in driving global cooling than other materials following the asteroid's impact. Dr. Kaiho responded to the criticism by saying that his previous soot analysis indicated that it had burned at a higher temperature than what is seen in soot from forest fires and that it almost likely came from the same source, which he said were the rocks at the Chicxulub asteroid impact site.